Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hello, and thank you so much for joining us at RAG Hacks on this live stream. My name is Nitya Narasimhan. I'm a senior cloud advocate on the AI advocacy team at Microsoft, and I'm joined by...
I'm Leah Simmons. I'm a senior product manager on the Azure AI Experiences team.
And today we want to talk to you about Retrieval Augmented Generation, but using AI Studio to build your first custom RAG-based copilot. By now, you're probably familiar with the term RAG, and you know what that involves. But what we want to do is teach you how to kind of build this from scratch by using an existing open source sample. So let's get started. The agenda for this session is really quite simple. First, we're going to start by describing to you an application scenario for the open source sample that we're going to focus on. Then we're going to walk through the 4 steps or 4 phases of our end-to-end developer workflow, and then wrap up by showing you how you can deploy and deliver a responsible and observable Copilot experience when you build your RAG application. Quick note, there is a GitHub link that you'll see there that will also be shared on the chat. That's where you can go to if you want to have discussions during or after this session. We'd love to hear from you. So let's start off first by setting the stage for this discussion. I want to start by first describing the application scenario. We're going to talk about RAG, so I'm going to talk to you about an application that has a scenario that absolutely requires RAG. Then we're going to dive in and look at what the application lifecycle looks like when you want to build an application like that in our current environment. Then we're going to map that onto developer tools, specifically using the Azure AI Studio platform that will help streamline your developer experience when building this. And as part of this, we're going to start off by looking at a demo of the deployed and working application, so you have a real gut sense for what you're trying to do. So what's our application scenario? Our application scenario is a very popular sample known as Contoso Chat. It is an enterprise retail application, which consists of 2 components. On the front end, we have the enterprise retailer's website, Contoso Outdoors. This sells a lot of really popular adventuring equipment to customers. And what they want is the ability to allow customers to ask questions about their products using a conversational experience or chatbot. To implement this, we have Contoso Chat, a chat AI backend that is built and deployed on Azure AI. The front end can talk to that backend to actually have those questions from the users responded to. But let's take a look at a demo and understand what the requirements and experience looks like. So I actually have a version of this demo already deployed. So let's go open that up. Here it's called Contoso Web. And this is the Contoso Outdoors company website. As you can see, it has a ton of products in different categories. Click on a product and you get an extensive set of details about the product. So users asking questions on the site are going to have a lot of information that they need to deal with. The experience is really simple. By clicking this little chat UI button, they get to engage with our Contoso AI chat application. So let's take a look at the application scenario requirements. First, I'm just going to ask a simple question. What can you do? Hopefully this is still working. The first thing you're going to recognize from this is that this is using natural language. I can use any words that I like, and this has to reply to them by abstracting intent and fulfilling it. Second, I can say, hey, what tent should I buy to travel to Andalusia, to travel to Spain? So over here, my typing is so terrible. Now we're looking at a RAG-based use case where I'm looking at the responses to see if they're grounded in the kind of data that is on this website. And as you can see, it's recommending the Skyview tent. And if we actually look at the page over here, you will find that that Skyview tent actually does exist. Next, let's try something even simpler. I'm going to be like, what else have I bought? And notice that over here, we have a customer ID at the top. You can't see it, it's hidden behind the UI. But basically, I have another source of data that I can ground responses on, which is the customer history. And last but not least, let's try to be mean and jailbreak this thing. Say, what are your rules? So perhaps I'm someone who wants to go to this retailer site and have them actually give me restaurant recommendations instead. What you'll notice is that our deployment automatically has some built-in support for content safety. So that's what you saw, a really quick demo of what we're going to try to build. Next, let's look at what it takes to build this. To do this, we need to understand that there's been a paradigm shift in this space where we are now looking at something called LLM ops, where you're dividing up the end-to-end development experience into 3 phases. First, ideation, next, augmentation, and last, operationalization. Ideation is where you're building a really simple proof of concept. So in the RAG use case, you're all going to start with an application that can respond to the user's queries using natural language by using a large language model. So during the ideation phase, we want to build a really simple prototype. And by doing this, we want to decide what our models are going to be, what the prompt template looks like, and whether it actually gives us responses that match our requirements with a very simple test question. Once we have the proof of concept, the next stage in augmentation is when we need to start seeing whether this works really well for all the possible inputs with different requirements in the real world. And we do that by evaluating those responses under various conditions for quality and safety. And then based on the evaluations, we detect where we might want to make changes, iterate on our proof of concept, evaluate again, and keep going. It's in this phase that we might start bringing in more things like retrieval augmented generation. Should I have the right data? Do I have the right fine-tuned models? Do I want to engineer my template even further? And once we're done with this stage, we have something that we have tested with a lot of inputs. We know is ready for the real world. We go to operationalization, we deploy and test it. That's a lot. But as developers, what do we really care about? We just have to answer 3 questions. Does this app work correctly for all these inputs? Next, if something goes wrong, how do I debug it? How do I figure it out? And last but not least, I'm a developer. I don't want to deal with the hassle of all the infrastructure provisioning, the setup of the development environment. I just want to dive in and get productive fast. So how can I simplify the setup? This is where developer tooling really helps, and Azure AI as a platform shines. So if we look at that from an end-to-end developer workflow, I want to kind of have you look at this from 2 lenses. On top, we look at the tasks that need to be done to build our application. We need to provision Azure infrastructure. We need to set up and maintain a local environment that everyone on the team has the same consistent environment with minimal effort. Then we need to ideate, build a proof of concept, rapidly prototype and prompt engineer it. Then we need to evaluate it and augment it until we get it to a stage where it's working pretty well for the criteria we've set up. And then we want to host it for access from the real world, and then have built-in support for safety and monitoring so we can get real-world insights and feedback that we can use to iterate. And as you can see, every one of these is tied to a tool. And we're going to look at how that works in just a minute. So let's get started. First, we're going to look at just the setup parts. How do I set up my infrastructure? And how do I set up my development environment to get started? So to do this, first, let's understand the design architecture for Contoso Chat and start working with a sample so we can get a hands-on look at how that works. So we're all familiar with Retrieval Augmented Generation. I don't need to tell you about it, but let me map this onto our architecture for Contoso Chat. So on Contoso Chat, the application that you just saw is the app that you see on the left side. it's talking to a hosted model. It could be directly a chat model, in our case, the copilot, or it could be the application that we wrote. Now, in our case, the copilot API is the hosted endpoint that exposes our implemented Contoso Chat AI to the real world. So the app sends its request to that, gets responses back. What's happening on the back end? That chat function, if we did nothing else, if we didn't have any RAG at all, would effectively take that query and send it to a large language model, get a response, and send it back. But those would not be grounded because those chat models have a lot of knowledge. They're not really grounded in my data. So to do this with RAG, we have this kind of like a little bit of extra orchestration required. First, the incoming request needs to be converted into a format that the machine can understand using an embedding model. So we vectorize the text query. Then that query is taken to a search service index that has chunked and vectorized documents from our data. And so we can use similarity search to find and semantic ranking to get back a subset of documents that match that query. Take those, and then, so that's the information retrieval part. Take those and then augment the prompt template that we have with both these documents and the incoming query, send it to the model, and now we have responses grounded in our data. This is Contoso Chat. Under the covers, this is going to require us to decide what our models are, have built-in services we need to use, have tooling to enforce responsible AI practices, and have a unified platform that will kind of manage all of this for us end to end. And this is where Azure AI Studio shines. But first, let's get started with provisioning our infrastructure. You saw that we had a bunch of different elements that we had to implement. So before I dive into what the Azure Developer CLI does, let's take a look at what the Azure AI Studio looks like. So if you go to Azure AI Studio, you can go to the model catalog to pick the models that you want and deploy them. You can go into the hubs. So a hub, an Azure AI hub, is like the resource that you might maintain at your organization or team level that manages the billing, that has like deployments that can be used across projects. And in that hub, you will have one or more AI projects. And those AI projects kind of are resources that focus on a single application, allowing to share state and maintain relevant resources for that particular application deployment. I'm going to let this wait up and bring this up in just a second. But to set up this backend, to provision these resources, to provision the Cosmos DB with my customer data, the Azure AI Search Service with my index, and so on, we need to do a lot of manual provisioning, which can be really complicated. This is where the first tool, Azure Developer CLI, comes in. You can go from your code to the cloud with a single command. With AZD, you go to your repository, log in and authenticate with your backend, and just do a single AZD up command, which automatically reads the templates that are available, converts them or provisions the resources required, and deploys your application for you. How does that work? Infrastructure as code is really about encapsulating all the configuration parameters, resources, and other information required as files that can be checked into your version control system to create a consistent infrastructure deployment mechanism across all your users. Specifically, for the Azure AI platform, at Build, we just released a whole bunch of Azure AI templates. So let's take a look at what those look like. There's a whole bunch of built-in templates that will cover a lot of popular use cases where they've already implemented that application. I'm going to look at Contoso Chat, the retail copilot that uses RAG. So if you want to follow along with us as we go through this exercise, all you need to do is click on that, go to Contoso Chat, fork the repo, start it up. I've already done this many times, but just for the heck of it, we're going to do that. Make sure you copy the main, or you can uncheck it to get all the different branches. I'm going to use the RAG hack branch so we can mess around with it a little bit. And once you forked it in your custom fork, all you do is create a code space. I'm going to let this run and get back to you in just a second. So what the template does, the AZD template, is it looks at this architecture, this functional application architecture. It provisions all the resources that we've identified here. And it also configures hooks that populate, or it also runs post-provisioning hooks that will populate the required data, set up the local environment configuration parameters, and deploy your application for you. So by the time you're done with AZD up, you actually have a fully deployed app. So over here, you'll notice that when I forked it, we're starting GitHub code spaces. This takes a long time. So I'm going to switch over to something that I've already deployed before. So over here in the Contoso Chat, I have a already running code space where I have done AZD up already. So as you can see, when I do an AZD up in this repo, it sets up two files for me, a .env file which has all the environment variables for my particular deployment, and a config.json that tells me which Azure project I'm using, my subscription ID, my resource group, and so on. So with zero effort, every member of our team gets the same starting point. So we've got this set up, we've provisioned the infra, and we can now validate the setup. So as I mentioned, this is actually deploying this application for me as well. So let's go check out what that looks like. Hopefully this has started. There it is. Okay, so if I go look at Azure AI Studio, my deployment actually looks something like this. Let's wait a second and check this out. So at the high level, at the top level, when I look at all hubs, I will have an Azure AI Hub resource provision for me, which has a specific project for Contoso Chat. And if I go and look into the deployments here, I will see not only the models that I'm using in my RAG design architecture, but also the deployed application. So we can go ahead, test this. We can find snippets of code to connect to it, monitor, and log. We'll look at all this later. But that's pretty much how easy it is for you to set yourself up to start working with our Contoso Chat sample. And in doing this, we've shown you two different features: the Azure Developer CLI with infrastructure as code, and GitHub code spaces with configuration as code, both of them allowing you to get yourself set up with minimal effort. Now it's time to jump into our application lifecycle. The very first stage is ideation. And here, we're going to have Leah talk to us about how we can do rapid prototyping and prompt engineering using prompty and promptflow. Leah, you want to take it away?
Yeah, thanks, Nitya. So Nitya's helped us set up our development environment, and we also have our infrastructure provision. So what's next? We talked about the multiple phases, and we're going to go through those step by step. And right now, we're in the ideation and iteration phase of our development lifecycle. So we want to build a simple proof of concept for our copilot, which is our chat AI, our API. And then we want to iteratively evaluate and refine to meet all the requirements that we might have. So let's take a look at this live. And Nitya's actually going to help us. We're going to work together to make this happen, and you can follow along.
Right.
So
go ahead.
Yeah. No, that's good. I think we wanted to show the Contoso Chat application folder, and then we're going to talk a little bit about prompty, which is what we're going to get into next.
That's right. So let me really quickly tell you that when we deployed this application, and if you followed along and did an AZD up, you will find that it installed this application with the prompty extension out of the box. And you can go ahead, if you use a RAG hacks branch of the repo, then you will get this. Otherwise, you can do it yourself. We've created the RAG hack demo folder, and we have a couple of sample prompties in there. So Leah, what should we do next?
Yeah. So we're going to get into prompty and how it works. Nitya mentioned that there's a VS Code extension, and that's actually something that you have in your code space if you're following along. Prompty has a language agnostic prompt asset that you can use for creating prompts, iterating on them, further doing prompt engineering, all within your local development environment. And prompty, along with some other features that we're showing today, are in preview, which means you can always look out for updates, and we're looking for ways to improve these experiences for you. So please reach out with what you tried out and what experiences you're looking for. So if we go into the details of prompty here, what are we getting with prompty? It's a specification, and it also is a fully fledged tool with a runtime that you can use within VS Code. It's easy to start. It's intuitive. It's really targeting the code-first experiences. It's language and framework agnostic. And it also really strives for agency with observability. What you're going to see throughout this experience is you can see the tracing end to end through what you're building. And that's what we're hoping that the code-first experiences with our promptflow SDK with prompty help you achieve as you build your applications. You're going to be able to develop functions and make model calls, and prompty is going to help you do that. And you're going to be able to see how this all works step by step. So if we look to the right here, you can see what the specification of a prompty file looks like. It's adhering to a markdown-like syntax with a modified front matter, which you can see at the top. And then there's also the system prompt and then any additional context you want to provide. So what prompty is letting us do is it's allowing us to connect to a model and have that model configuration defined directly in a file. And what we'll see later on is how we can actually integrate that into our application code. We're looking at the three components that prompty has here. It's a specification, and then the tooling, which we're going to play around with here with Nitya's help. And there's also the runtime. You'll see it in action. And it's how we're going to convert this function-based approach into integrating it with our complex app. So let's take a look at what this is. Yeah, let's jump in.
Let's jump into the demo. Okay, so we're going to switch over to the deployment on Codespaces. The one thing I'll tell you is that we've got this set up with an environment talking to our backend infrastructure and all the environment variables set up. So Leah, should I go ahead and try to create a new prompty?
Yeah, so because the extension is integrated here, we have this RagHack demo, which Nitya mentioned you can create if we follow along. And if we right-click here and just select New Prompty, it's going to load up this prompty file. And just like the screenshot that we showed, you can see this beginning section has the specification of the model. We have sample code, and we have a sample here for running the prompty, and we're going to see how that works in action. We have a system message. With those familiar with prompt engineering will be familiar with the system message you pass to the model. And then we're also going to integrate with some context here. So if we go up to the first part, Nitya, if you don't mind, you'll see that we have a model configuration. And in line, let's see, 10 and 11, there's a specification here that we can put. We have an environment variable, as we mentioned before. We can add that in, and we'll be able to run this out of the box.
So I'm just going to go ahead and copy this from one of the prompties I already have, because we know that that's the environment variable that's set up for us. So let's save that. And by the way, I love the fact that this context is effectively giving us a really lightweight version of a RAG because it's grounding the data with this particular item. That's pretty cool. So
yeah, absolutely. Yeah, so let's talk, before we run it, let's just go a little deeper into that example. So that's exactly right. Nitya and I are here collaborating. We're trying to figure out how can I use this in a basic example, but know that it's going to help me get where I need to go. And so here in the context, this is a very basic example of what we might do. Like it's fake RAG, right? We're giving it some context, we're grounding it in some information, and it's going to take that and answer the question with a little bit of extra context. So because the prompty extension is integrated here into VS Code, we're going to be able to run it out of the box, and we'll give that a shot.
Here goes nothing.
So here we can see the runtime. It's using a default model configuration that we've specified. And there we go. We know the model that we're calling. We see that endpoint, and we get a response. Prompty is known for its fun emoji-like experiences, and you can see that there.
I love this. I mean, one of the things it says is this is like having your playground right in your IDE, and I love it.
Absolutely. It's great. So now that we've created the prompty, we've updated it, and we've run it, let's actually try changing a little bit of the context to see how it behaves differently. So we talked about how this was a little bit of fake RAG here, and it was actually able to answer our question. We said, what can you tell me about your tents? And it's telling us about the Alpine Explorer tent because that's the context it has. What if we hadn't provided that context? What do we think might happen?
I don't know. Let's try it. So now there is no context nothing to say. So there is no context now that can ground it in the data. So shall I run it again and see?
Yeah.
All right, let's do this.
Okay. So here we have what looks like a little bit of a more generic response. It's saying, I'm happy to tell you about our tents. Our tents are made with durable materials, but it doesn't actually have that context. So we're not getting back the Explorer tent specifically. We're getting some general information about tents, and the AI assistant is trying its best here to help us. So this shows us how we can test very basically a prompty. We can use the extension to test that out. It shows you just how easy it is to create, configure, and iterate on a basic prompt template, and it's all within your local development environment. But our use case is more complex. We are going to have to integrate and work on an application that works for a Contoso Chat, fully fledged application with a website, and we want to get you there. So we're going to go into how we'll use more complex examples and implement this using prompty, but in our chat application code. And one more note that Nitya wanted to make sure I didn't forget to share. is that was a really simple example, right? We just put that context straight in there. It just had a question and it had a little bit of context. But you might need to test in a basic example your very specific customer use case. In this case, we have a customer ID, we have a question, there's going to be chat history. You might have a lot of data that you need to put in there. And so the prompty file will accept a file that gives that context, and you can just bind that data right into your prompty file. And so we're going to keep going. Just as a subtle plug, if you want to learn more about prompty, we did a presentation on end-to-end application development with prompty at Microsoft Build this year. So we definitely hope that you'll check that out to learn a little bit more about prompty. But for now, we're going to go to the next step of this, which is actually getting into the nitty-gritty of how do we build this end-to-end application. So what are we going to have to do? Nitya talked to us about this already before, but we are going to need to reference multiple data sources because we have different places we need to pull that data to make it a fully grounded, good customer experience. And to do that, we're actually going to have to orchestrate all those things we have to do. We'll review the architecture in a moment, and we're going to do it with prompties by actually bringing those prompties and orchestrating them together to make those model calls, bring in our RAG-based capability, and have a pretty awesome application. So let's review it quickly again, the architecture that Nitya showed before. We've now talked a little bit more about those details. So like we said, we're going to have our user input, and then we're going to need to go to our Azure OpenAI service. We're going to need to go to our AI search. We're going to need to go to our Cosmos DB to pull in all the information that we need. So looking into a little more detail, the Azure OpenAI is going to be that model deployment. The prompty asset is going to let us specify that and help us make that call with all the configurations that we want. Then we have Azure AI Search, which is going to provide our product catalog index. So that's our data. That's where we're going to do our search retrieval and make that RAG come to life. And the prompty file, like we're about to see, is going to expect that as input. It's going to say, I'm expecting that you have retrieved me the correct documents, and I'm going to use that document as context. And that's our retrieval step. And then we have Cosmos DB. That actually has our customer purchase history. This is how we personalize this experience in our website for the customer that's talking to our chatbot. And all of these things are inputs that our prompties are going to expect, and our code is what's going to orchestrate all of that for us. So a little preview, we're going to orchestrate this code used by first retrieving relevant documents, loading the prompties and populating it with that retrieved data, and then executing the prompty to get the final response. And we're going to write that code that's going to help us do that.
Awesome. So
I'm going to mention that this is going to bring us to one more tool, which is the promptflow CLI, and Nitya is going to help us take a look.
Yeah, so I was just going to make a quick note to say that when we build this basic prompty, you can always start with this default one. But based on what Leah just said, let me show you where the Contoso Chat application is in this repo. It's under the Contoso Chat folder. And as she just mentioned, the application template is defined by chat.prompty, but this is just a static asset. It's just a static file. It's not really doing anything. The tooling and the runtime is what converts this prompty asset into a running kind of like micro-orchestrated application where you can test that single function against that single model. So this is chat.prompty, and I'm also going to open chat.json so you can see both of these next to each other. But should I run the promptflow tool right now? So
let's get into it. So we're going to look at how we execute the prompty, not through the extension, but actually as a part of the code that we've written. And to do that, we're going to use the promptflow CLI. So Nitya, as we do this, we're going to make sure that we're in the folder of the directory, which I think you are. And before you run this, let's just break down this command a little bit. So PF is that CLI, and we're using the test command. This is going to let us run from the command line, run our whole orchestration code. Now, this is a sample that you have. Nitya showed you that this is a template. All this code exists, and you can modify it to fit your own use case. Right now, the code does simple steps. Actually, I shouldn't say simple, but just the few steps that it takes to orchestrate what we want for Contoso Chat. But you can, of course, expand and modify those steps to fit your use case. So here, our chat application expects 3 pieces of input. It expects a question, it expects the customer ID, and it expects some chat history. that is how it's going to personalize the response. And let's take a look at what happens when we
Yeah, and before I run it, I'll also just make a quick note to say that when you did this minus flow with the Contoso Chat, what it does is it says, look inside Contoso Chat for some configuration file that tells me where the entry point for this flow is. And so you can see that I've told it it's going to look for this YAML file. And as Leah pointed out, it has 3 inputs. And this configuration tells you that, hey, I expect these 3 inputs of these types. The entry point is this chat request module with this get response function. So now if we run this, shall I go ahead and run it?
Yeah, go ahead. And as it's going, we're looking at that entry. This is a function that we're saying this is where everything starts. Our orchestration is really a collection of functions, and we're going to go through each of those pieces.
So while this is going on, I'm just going to switch over to show you the chat.prompty. And you will see that the inputs are taken in here. And did we already look through the template here, Leah?
No, this is great. Let's take a look at it, and we'll look at the output that we got.
Okay. Meanwhile, let me just open this. I just wanted to highlight the fact that we have the trace view already ready. I'll just go ahead and open that. It's on port 23333. So I'll just say that if you're running this in code spaces, you don't want to go directly to the URL. You want to go to that port and open it in preview, and it should actually open that up in your browser tab right there. You're going to see a whole bunch of rows because I've been running this all day, but the latest one is actually here. So let me stop now and ask Leah where she wants to go next.
Absolutely. So we're going to break down what happened with this run. So now that Nitya set up all the pieces, there's a lot of output here. You can see that actually there is a lot of orchestration happening. We have different functions being called, and then we have some output, and then there's some parsing that's happening for that output. What if we dive into the code of what's happening? This is going to look like a prompty file. And so if you could go to the chat.prompty.
Yep, here it is.
Yep. So looking back to the top, let's just review again kind of the structure of this file. We have our title, we have our description and our authors. This is, again, part of that modified for prompty and what we think will help developers the most. We have our model specification, so we can see this is calling a GPT-3.5 turbo model. We have some parameters. And then like we already saw, we have those expected inputs, which is our customer, our documentation context, and our question. We have our system message, and this is going to look a little different than the examples we've seen so far. And then really importantly here, we have our safety measures. This is a lot of prompt engineering. So that whole section there at the bottom is all about what do we want, what guardrails do we want, what do we want to ask the model to do so that we get our expected response. And if we scroll down a little bit more, we can see how we're going to fill in that content based on the information that we've retrieved. And so let's now take a look at the trace view that Nitya loaded up. It's going to give us a really nice step-by-step process, and this is that observability that we were talking about. I think, Nitya, just in case, can you zoom in a little bit? It might be small for our viewers.
I think so. I think you're right. Let me see if I can.
Perfect.
Is that better?
Yes, that's great. So we're looking here at the whole flow. That's the Contoso Chat folder that Nitya showed you before. Get response is the main deal. That's the thing that matters, is getting that response. But there's pieces to that puzzle in order to get that final result. So we can see that we're calling an embedding model. That's what we talked about in the architecture, where we need to vectorize that query. And then we can see how we're loading that prompty. And for the prompty, there's functions involved there. This really is just a function, and that's aligned with the model call we want to make. It is parsing out the request, and then it has that input and output that we're looking at here. And then we get into the nitty-gritty. We get into the LLM call. And the exciting thing about this is this observability is going through all the way into the OpenAI model calls. So we're not just looking at our code here. We're actually looking all the way deep down to that call. We can see the system message that's passed in, and we can see the assistant response. And this can be really helpful for debugging. You can really see what's going on behind the scenes here. So let's review what we've looked at so far. Okay, so this shows you all the pieces that Nitya loaded up for us. We saw how we run a CLI command with promptflow that lets us specify the inputs that we want. We saw how there was a output. It gives us our trace view that we can view locally. And we can see that the raw output that then will get processed. We can see a trace view like Nitya showed. It shows us that step by step. Like we said, that It's the observability that we're looking at. Okay.
I think this
So-
is just showing you the bits of the trace view that we already covered.
Yeah, exactly. So this is just a little bit deeper. We already talked through each of those pieces, but we wanted to make sure that these slides were here so that you can follow along with this. Okay. We also already looked a little bit at the chat.prompty. That showed that breakdown. We walked through it. And what this lets us do is really develop, like we are showing how you can use these templates. You can use prompty to orchestrate context from multiple data sources. You can add your instructions. You can add your safety rules. And you can really see all the way through how those things are working in action. All right. So we've developed our copilot. Now, how does it work? Does it work well enough? We've only used some kind of really simple data here. We need to prove that this works, and it works continuously and with larger data sets. So Nitya is going to help us learn about evaluation.
Yes, and this is actually one of my favorite parts of the whole end-to-end developer workflow. So if you've been following along on the boxes at the bottom, we've covered the provisioning of the infrastructure, setting up of the environment with code spaces, looked at prompty and prompt flow for how you can repeatedly iterate and ideate until you get a proof of concept. But the problem is we are testing it with a single input. That's not really reflecting the diversity of inputs that happen in the real world. What we need is to evaluate our application against a broad set of inputs. How do we do that? Well, with Azure AI Studio, we're going to talk about two different things. One is how the process of AI-assisted evaluation flows. And second, the criteria, the quality and safety metrics that we can then use to assess the quality and safety of our solutions. So let's dive in. In this section, I'm actually going to take a little bit of time to sell you on an analogy for what AI-assisted evaluation means. So if you look at the evaluation strategy in an end-to-end workflow, we all will start when we kind of start our ideation or proof of concept. We might just put something in a playground or use a prompty, iterate on the prompt, try it with a single input, and we're really doing manual evaluation, right? We're trying it out, looking at the response, saying, does this look good? No, let me go change the prompt again. Oh, this is not grounded. Let me add some data. So we're playing around, and that's manual evaluation. But the minute we want to actually have this tested against diverse inputs, we need a way to automate it. And this is where AI-assisted evaluation helps. With AI-assisted evaluation, what you're doing is you're getting one LLM to grade the other. In other words, the original LLM, which I'm going to call the chat LLM or the chat model, its job is to generate a response to the user query. Now we can create an evaluation model whose job, or evaluation AI, whose job it is to grade the responses provided by the first one, where the template that the evaluator uses has a different set of instructions, has a different context, has a different set of criteria that by which it actually scores those responses. And what this allows us to do is not only automate and scale our evaluation process, it allows us to then take it into production, put it into a CI/CD pipeline, and actually have this run on every commit. So what exactly does one of these flows look like? Remember that when we think about evaluation, we have to keep two different criteria in mind: quality and safety. Now, for a lot of reasons, we can't cover everything today. So I'm going to talk about quality first, because that's what we focus on in Contoso Chat right now. With application quality, the process for this AI-assisted evaluation is as follows. First, you need a data set of test prompts. Remember, we tested with a single prompt. Now you need a set of representative prompts. You want to capture enough prompts for various edge cases. You take this data set of test prompts and you feed it to your chat AI, which then generates the responses. Now you take those responses and you feed it to your evaluator AI, which then grades those responses and delivers the evaluation results. So what does the quality application quality result board look like? Well, it gives us a whole bunch of metrics. There's a bunch of them listed here, and you can learn more about them in the documentation. But we're going to look at 4: coherence, fluency, groundedness, and relevance. Groundedness is really saying, hey, if I gave you some data context, and this is really useful for RAG, did the response actually get grounded in the data that I gave you? Fluency says, hey, if I looked at this response, does it sound like a human did it? Like, does it sound smooth and well-written? Coherence, am I mixing them up? One of them is looking at like spellings and all. Coherence is saying, is this put together well? And last but not least, relevance says, at the end of the day, did it answer the question? So how does this actually work? We'll look at that for the Contoso Chat sample in just a second. But I'm briefly going to talk about application safety evaluation and how that differs. The main difference is when we're evaluating for quality, we kind of know what the test prompts are going to be. That's maybe even our requirements, and we want to make sure that we have the criteria for testing it. But for safety, we're actually thinking, what are the things we don't want to have happen? And you may not always know what that could be. There are no example data you can pull from. This is where AI Studio offers tools like the adversarial dataset generator, which will actually generate the kinds of prompts that would violate your safety guidelines, and then test if your evaluator can actually see that those don't occur. What are those kinds of metrics? You can see a list here, and there's actually a lot more covered in a recent MS Build talk. Not to mention, Pamela is doing a session on RAG evaluation next week or on 12th, so check that out. But before I kind of dive into the Contoso Chat demo, let's really quickly look at what's coming up next. So Contoso Chat right now is still using slightly older approach to evaluation, but recently at Build, we had a session and some new tools and that are currently in preview released to help you make this even better. Key among those is this notion of evaluators, a library of built-in evaluators, including evaluator prompties that you can use to run these kind of tests, along with the tools to generate your adversarial data sets and more. So if you want to learn more about them, go check out this MS Build session, or that's on 12th September, there is a session with Pamela and hopefully me that will talk about evaluating a RAG chat app in more detail. But for now, let me see how the time looks. I think we still have time. So let's do a quick demo. I want to show you what the evaluation flow looks like in Contoso Chat. So over here, I'm still in the same repository. And what we're going to do is we're going to look, and if you're following along, look in the evaluation folder. So over here, you're going to see three things. First, remember, we need a data set, something that gives us a bunch of test questions, test prompts that we can give to the chat AI to have it generate the responses that we then need to evaluate. In the evaluations folder, currently I have this as a notebook. We're going to convert it. This is going to be updated and refactored to use some of the newer things. But the notebook helps us by showing us clearly what the steps are. What we do is first, we initialize our connection to the evaluation. So here we're using GPT-4 as the model that's going to evaluate the GPT-3.5 Turbo, which is our chat AI model. So we set that up. Then we actually find out where our Contoso Chat AI resides. And we load up the data from these test prompts, and we feed it to that Contoso Chat and have it generate responses for each and every one of those test prompts. Once those are done, it stores it in a local results.json file, which you see right here. I already ran this once, but you can run it again if you're following along. So once that has generated the results, what we then need to do is have our evaluator evaluate these responses. And what you'll see here is that we're using prompties again. So over here in the prompty folder, you will see multiple prompties. Remember, a prompty is like a single function associated with a single model. Each one of these is associated with the GPT-4 model, and each of them is set up with criteria to assess that particular metric. So for example, if I want to look at coherence, it says, hey, what is coherence? You're an AI assistant. You're given the definition. Coherence is this. And it gives you a bunch of examples to tell you how to score different kinds of test results for coherence. So with this, if I go back to this code, you will notice that I first load up all those prompties. And then I can actually, when I load up a prompty, I'm getting a bunch of functions that I can call. Then for each of those, I'm going to feed it the responses from the chat AI and have it assess the results, which get written to a new file over here, results evaluation. For simplicity, we've just kind of rendered it here locally so you can see what those results look like. And now you can see that for every question, this evaluator prompty with the evaluator flow goes ahead and ranks it for those various criteria. Fairly simple, right? But think of what you could do if you could write more powerful custom evaluators, what you could do if you added the safety evaluators and more. But I think we are kind of need to wrap this up. So let's quickly take a second to talk about the last step. We've now used the evaluation step to make sure that our application works for a broad set of use cases, has fairly decent metrics, and we're ready to deploy it in the real world for users. Leah, what do we do next?
Yeah, so thanks, Nitya. We've gone through 2 of our main phases, and now we're moving to phase 3, which is the operationalization. That is a mouthful, operationalization. So our next step, now that we feel confident in our application performance, we're ready to deploy. And like we talked about before, we actually already used AZD up, which included provisioning an endpoint, and we had that deployment. Now we've made some changes, and we want to easily redeploy, which means it's allowing us to do iterative deployment as we make changes back to that endpoint. So that managed endpoint lets us have multiple deployments. It lets us allocate traffic. And the benefits of it are, like I said, it's managed, but it's also you get built-in responsibility, and we continue to have that end-to-end observability. And we're going to look a little bit at what that deployment experience looks like in Azure AI Studio.
Okay, before I do that, I'm just going to go quickly and grab a sample input that we can use to test this out because here it is. So we're going to use this as our sample input for testing. So now I'm going to switch over to the deployment. So Leah, as we kind of showed before, this is AZD deploy up front, already deployed the application for us. So it's right here. This is the detail.
Yeah, exactly. Yeah. So if we had gone into this deployment here, you can see that it's in a good state. It succeeded. If we had redeployed, it might take a little bit of time, and we'll be able to see that status as it's redeploying. And then when it's ready to go, we can go ahead and test it out. So as we've seen throughout this, our application, our backend API, expects 3 inputs, and it expects them to be formatted as a JSON object. So that's actually the object that Nitya went and grabbed. And I think you might be missing one closing bracket. We'll see if I'm right.
No, I think it's okay because
it's there.
This actually validates the JSON. Oh, so there it is.
So yeah, perfect. Can you zoom in a little bit, Nitya? It might just be just in case other folks. So we have here our input. I can see that bracket now. And we provided that input and we can test it, and we can actually see that output. Now, the response looks pretty similar to what we saw in our tracing and in our local testing environment. And that's good. That's because we used and tested with Azure AI tooling throughout this whole end-to-end process. We can be confident that our application is going to perform the same in the deployed environment as it did locally. So there's also, looking here, we've now tested, that was our test inference. Like Nitya showed before, we can consume through code. There's code snippets there to help us. There's also monitoring, and that is, again, part of that end-to-end observability. We want to be able to monitor how applications perform in production. This is in preview, and so we'll continue to iterate and improve this experience. But we just want to highlight kind of what working with your deployments in AI Studio gets you. Okay, so that showed a little bit about those capabilities. Now that we have verified our API, we're ready to integrate it with our Contoso website. This is something that Nitya showed us earlier on, about like 40 minutes ago. And we can now update our website with this new deployment, and our integrated chatbot will be ready to help our customers. And it's going to showcase that RAG capability that we orchestrated.
Yeah, and if you're interested in doing this step as well, the sample is really called Azure Samples Contoso Web. That's the front-end code. It's a Next.js app. And it has a couple of environment variables. I went ahead and actually deployed this as a static web app. So I can go ahead and set those environment variables. All you need to do is go into your Contoso Chat deployment right here, go into the details page, pick the endpoint and the key, copy that over into your promptflow endpoint and key variables in the static web app, reload to deploy, and that's your deployed application right here.
Do we want to see it in action?
Yeah, let's do it. So let me actually reload it. And hopefully sometimes the first time it glitches because it takes a little bit of time, but you might be lucky. Let's say, give me a question, Leah.
Which is the best tent? Which is the most waterproof tent?
Oh, waterproof. Which is the most waterproof? You had to make me type, didn't you?
Typing when people are watching is the hardest thing.
I know. That was exactly what you said. I built it. I remember it so well. All All right, so this is a new thing, and there we go. So it is actually talking to that application. And if you had put in kind of, I think if you look at the logs, you might even see that the request went through. So I'm looking at the time. We had.
Oh, that's great.
Yeah, we kind of completed the demo showing how you can integrate it into the application. I do want to just briefly mention the fact that if you look at the deployment and the consume tab, you will have example snippets for various front-end languages. So you can actually try to do this with other applications or even from the command line or curl. So last, do we want to kind of go ahead? Anything else that you want to say?
Yeah, I think that's great. I think we showcased the application. We built it, and we have it end-to-end working in our website. And so we can move on to wrapping up.
All right. So if you did follow along, one of the things I really like about AZD is that if you've been deploying all this infrastructure, you will notice that it's actually kind of really difficult sometimes to make sure you clean up correctly. All of these could have costs. Model deployments have costs. The Azure AI service has costs. So the easiest way for you to clean up, if you provisioned with AZD, is to do an AZD down. Part of that, as you do an AZD down, is it gives you the option to purge any of these resources that are held in soft delete mode. And that means that when you actually do delete your resource group, you can reclaim those names and any quota. So if you were following along, or if you watch this later and you do follow these steps, don't forget to do an AZD down to make sure you release the resources at the end of this. But I'm actually going to take a minute now to wrap up. Now, we did this is a really kind of speed read through the Contoso Chat app sample. But I really want you to take away two things from this. First, when you want to learn anything, there are two ways to do it. Either you build up or you tear down. So if you want to look at how to build a RAG-based application bit by bit from the ground up, go check out the Azure AI documentation for a RAG tutorial with an associated sample. If you want to learn how an enterprise scale AZD template with all the dressings is done, that's when you'd go to something like Contoso Chat, tear it down and see how that works. So fork it, change it, bring your own data and see how you can work with it. The steps for it are, as we talked about, provision Azure, add your models and data, add your connections. Most of the stuff is done for you by the AZD configuration. Build your prompt flow, evaluate it, deploy, and use it. So what did we learn today? Again, that's the link to our discussion forum. If you have questions, comments, feedback, something didn't work, please do let us know. Love to hear from you. But what we really understood today is, hey, how do you build this? There's an application lifecycle. What is LLM Ops? What is the Azure AI platform? Really, that's a developer tool story. So your developer experience in doing all the steps of this lifecycle is simplified. What is Contoso Chat? That is a flagship sample for a retail copilot that uses Retrieval Augmented Generation for a code-first solution on Azure AI Studio. And in reality, what you saw were the different components of building, evaluating, and deploying a RAG-based copilot on Azure. What can you do next to skill up? I just want to give a shout out to the Azure AI templates link that I've put up here. Contoso Chat is just one of many such templates. There are others, a creative writer, which is a multi-agent or agentic AI experience, again, using prompties. There is one that kind of shows you how to do summarization. Go check them out. There are also samples that work in other languages. This is a Python-based sample. There's one in C#, and so on. There are also ones that use other orchestration frameworks. We use promptflow. There's a sample at LangChain. There's a sample at Semantic Kernel. Last but not least, the Azure AI Tour is just about to kick off. It's going to go around the world, and we are going to have a 1-hour workshop where we walk through this Contoso Chat application step by step. All you need to do is bring a computer. So want to sign up at a city near you, go check out that link. And I think with that, we are at the end of our session. I think we have a few minutes left. So is there anything else that we should be talking about, Leah? Anything else that you want to bring up? Or if there are any questions or any comments, we can take them.
I think that's great. I just want to call out how valuable we have all different ways to help you learn. Everyone learns differently. And so there's all these forums that you can use to try things out. I think someone in the chat asked about, like, if you're really getting started and just have the basics, where can you start? And I think we have some really helpful tutorials in the Microsoft documentation that aren't full-fledged templates and applications, but they're tutorials that let you step by step learn how to piece these things together with code snippets. So I would definitely recommend that.
Also, I will say that if you actually fork and use the Contoso Chat sample, you'll find there are various branches, and we will be updating the documentation and some of the code very shortly to bring it up to par with the latest tools. But you'll find various branches. The main branch is the deployment for the AZD template, but you can also check out the RAG hack branch, where I might put a few more additional samples and tutorials that you can kind of try out as micro test lessons. There's also an AI tour branch that will have a self-serve workshop that should be ready by the end of September. So check those out. And also, once again, this is the list of AZD templates. So if you want to go try out any of the others, all you need to do is click one of these links, go to the GitHub repo, launch the code spaces, run AZD up, and get started with the open source. So with that, I think that's kind of bringing us to the end of our session. I will say one last thing. We do have a Discord. I'm not sure if the link is available. Otherwise, we'll put it in the discussion forum. We have an Azure AI Discord that basically has a whole bunch of advocates, product team members, and large members of the community. We're hoping to put together office hours for some of these sessions. If you would be interested in an office hour to talk more about the sample or about building RAG-based applications on AI Studio, please do join the Discord and raise your hand and let us know, and we'd love to support it. And and with that, I think we should wrap. Anything else that we should be doing, Pamela, Daniel? All right. Let me see if there are any comments here. There's a so were there any questions? I'm just reading the comments right here. Question on promptflow with local SLMs. So we should be able to put, I think because there's a discussion, let me actually go to this GitHub and see what that looks like. What I'm going to recommend is that you put your questions on the discussion board right here. And once we kind of hop off the stream, we could go ahead and try to fill them in. So once again, the link is right up on the screen. And if you just put them in there, we should be good to go. Until then, let me go read the comments. All right. Excellent. So thank you all again. And hopefully we'll see you around. Don't forget there's an evaluation session next week on September 12th. And look forward to seeing what you build with RAG.
Thank you.
Hey, everyone. Hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.